Okay, ready to roll? Okay, first thing we want to do is do our free body diagram. Okay, we have weight coming down. What do we have going up? Sitting on a surface, yes, so normal. Okay. What else do we have working on this thing? We have friction. Which way does friction go? Friction is like force normal. Friction is a reactionary force. Guys? Like force normal. Friction is a reactionary force. It's going to go against, just like normal, it always goes against the other applied force. Okay? And then we have a force applied. What do we do with that?
Split it.
We want to break it up, right? We can't deal with this, but we can deal with that, we can deal with that. So, we'll go with force applied Y and force applied X. Right? Now let's get some numbers on these things, okay? So, what's our weight? Weight is equal to m times g, correct? So, 25 times 9.8 is, I don't want to write that out. Equals what?
245.
245, thank you. Sorry, Caroline, I just couldn't hear. We need to break up this, so that's a matter of doing a little bit of geometry here. Our angle is 25. This is our opposite leg, and this is our adjacent leg. And this leg is 100 newtons. That's our hypotenuse. Okay, so to find the y, that's opposite, so that's going to be sine of 25 is equal to Fy over 100. And for Fx, that's going to be cosine of 25, which is equal to Fx over 100. Okay? Somebody calculate those out real fast.
X is 90.63.
So Fx is 90.63.
And Y is 42.26.
Okay? So we can put those up here. And 42.26. Okay, now, what are we looking for? We're looking for net acceleration, right? Okay, which direction is that going to be in? The x. So let's write down our x equation. Okay. It says what is our acceleration, right? So that means F net is equal to m times a. Remember, you have two different possibilities for F net, correct? F net could either equal m times a, or F net could equal 0. When does it equal 0? Constant velocity or not moving, okay? So in this case, F net is equal to m times a, and what are our forces that we have in the x direction? We have force x and we have force friction. Okay, so m times a is equal to force in the x minus force friction. Okay, we have F in the x. Okay, we know the mass of the object, but we need friction. How do we find friction? Okay, Okay, friction, we have to deal with everything that goes in the y direction, right? So let me get a different picture here. Let's just deal with the y direction only. Our weight was 245. We had a normal, and we have a force in the y of 42.26.
Yes, 42.26.
Okay. All right. What's my equation?
245 plus.
What's my equation for friction?
Weight plus force in the y direction.
Force friction is equal to, what's the official equation for force friction? Mu times normal. Okay. So we have to do, is this moving up or down? No. So F net is equal to 0 in the y direction. Okay? That means 0 is equal to normal plus Fy minus W. So I can solve for normal. Normal is equal to W minus Fy. Down here nice and low. So, normal, the reactionary force, is equal to 245 minus 42.26. What is that? 202.
2.7.
74. Right? Do I know mu? What's mu? All right, so force friction is
50.675.
50 point.
675.
All right. Now I can take this back. And I can say, I know that force friction is equal to 50.67. Let me get 68. Now I have this, and I know my mass. Can I solve for acceleration? So 25 times acceleration is equal to 90. And you can solve it from there. All right.